Hello folks, you're welcome once again to another fascinating mathematical video. In this video we shall be solving this particular equation. It's an easy equation, but at first sight it seems as a monstrosity. Forget the monstrous sight you are seeing here. We're only interested in the techniques that we use to reduce this equation to a simple one. I would like to inform you that this platform also offers a personal tutoring. So if you're interested in a one-to-one tutoring, that is a private class with me, that will be run online, you are very free to DM me. You can reach to me through the email I provided above this page, or you've clicked the link and it will take you to my Telegram page whereby you can discuss to me in person. All right. So if you're interested in a private class, you're very free to work with me. Also, the Telegram link will also lead you to my group where you can see a step-by-step breakdown of concepts that are taught in mathematics. All right, so let's go over to the solving of this particular problem. As I say, it's very easy if you know the right thing to do. Now, solution. This particular problem, we're told that x is bigger than 0 and y is bigger than 0. So that means it is not expected to choose uh, a non-positive result. That is, if the result is 0, the value of x are 0, x and y are 0, those values are to be discarded. Then if we observe that in the process of solving, the values of x and y are negative, they are to be discarded. We only admit positive values. All right. Now, what we do, we shall simplify this equation considerably before we solve. Now, if you look at the equation, we have two equations given here. The first is like a monstrosity, while the second is very simple. Look at it over here. So the first, though it look like a monster, we can simplify it to a considerable extent. Now, the first equation is made up of the left-hand side and the right-hand side, all right? Now, we simplify the left-hand side and the right-hand side in turn. So let's start with the left-hand side. And the left-hand side, as you can see, is equal to writing xy over x plus y to the power 3. Let me just go straight up to things instead of wasting time. Now observe in the equation, you will see that the product sy is common to each term of the left hand side. So factoring, we have xy multiplied, and then we're left with 1 over x plus y to the power 3, multiplying 1 over x to the power of 3 plus 1 over y to the power of 3. Then plus, we're left with 3 over x plus y to the power of 4, and this is multiplying 1 over x to the power of 2 plus 1 over y to the power of 2. That's the second term. And the third term, we left with x6 over x plus y to the power of 5, and this is multiplying 1 over x plus 1 over y. Then we'll close the coiling brackets. All right, so this is the left hand side, and what we do, we strive to simplify the left hand side as far as possible. All right, now there are various opinions on how to carry out the simplification. Some people may prefer taking the term at once, that is the three terms at once within the braces. They want to take the three terms at once. That is all right, but that will seems very laborious. The labor will be too much, and when something is too laborious, it tends to make mistake. All right. And some others may think of taking two terms at a time, which is logical, and that is the method we want to adopt in solving this particular problem. All right. Now, because of experience, I will decide to take this. This is 4. Please take note. I will decide to take these two terms, 1, 2. You can take the first term and the second term, but you need more manipulation if you take that route. All right, but on taking the third term and the second term and the third, that is the last two terms, it will be easy. Easiness will come by in this approach. All right. So in this case, we can write this as equal to xy multiplying. Then we have 1 over x plus y to the power of 3. Or multiplying 1 over x to the power 3 plus 1 over y to the power 3. We'll close the brackets plus Now, this we want to manipulate as follows. This is s plus y all to the power of 4, all right? So now take note, this you see over here. This is a second term. We can write it in a very interesting manner. But before we do anything, observe that we can write this last term, that is the last term, not this one I'm writing now. I mean this last term over here, this one, 6 over x plus 5 to the power of 5. Now, if we work on this square parenthesis in this last term and simplify this expression in this place, this expression you are seeing here, we shall have it as x plus y over sy as a result. Can you see that? We have this as a result. From whence this we cancel out with this denominator over here. That is, I mean something of this. I mean this expression you are seeing here, we cancel out this expression you are seeing here. Can you see that? So take note of that. Or this. All right, so it will cancel out. So in that case, we have the result again as xy multiplying 1 over x plus y to the power of 3. Then we have 1 over x to the power of 3 plus 1 over y to the power of 3. All right, plus we have 3 over x plus y to the power of 4 multiplying 1 over x squared plus 1 over y squared. Can you see that? Then plus. Then when this cancels out, we have 6 over x plus y to the power of 4. Can you see what I'm saying? Then we're left with 1 over sy and close the bracket. So the thing is getting simplified gradually. So we continue the simplification process. In this way, we have the answer as sy multiplying 1 over x plus y to the power of 3 or multiplying 1 over x to the power 3 plus 1 over y to the power 3 plus 3. Now, if you observe carefully, now the second term and the last term has something in common. Can you see that? We have some common factor. Now, if you observe carefully, you see that 3 over x plus y to the power of 4 is common to both terms. So bringing it out, we have the result as 3 over x plus y to the power of 4. Can you see that? Then let me put a curved bracket to distinguish the results. So when we factorize in this way, we have 1 over x squared plus 1 over y squared, all right? Well, what we have for the second term. Then the third term, what we have remaining is 2 over sy. Now you agree with me that the expression is getting simplified. Can you see the progress? All right, so the next thing we want to do is to all right, is to simplify further. All right, let's do a further simplification and see what we come at. So this will be equals to writing sy multiplied 1 over x plus y to the power 3 or multiplying 1 over x cubed plus 1 over y to the power 3. Then we have plus. All right. If you okay, let's continue before I make my comments. We have 3 over x plus y to the power 4. Then this in the curved brackets can be written as x squared plus y squared over s squared y squared. Do you observe that? Then plus 2 over xy, close brackets. Hope you can see that. All right. Then I'll close this final bracket. Can you see what is going on? Rather, I will in order to avoid confusion, I think I have to remove these brackets. All right. I think it's proper in this way. Then also, I think I will still do this so that will avoid confusion. All right. I think in this way we shall avoid confusion. So we have this at hand, and which can also be further written as sy multiplying 1 over x plus y to the power 3, or multiplying 1 over x to the power of 3 plus 1 over y to the power of 3. Then plus 3, we have x plus y to the power of 4, all right? Multiplying this large expression. Can you see that? Then if you observe carefully, you see that sy is common at the denominator. So because sy is common, I can easily bring out sy in this manner. Hope you are seeing what I'm doing. Like this, then we have the result as s squared plus y squared over sy. We'll be left with sy here. Y here will be left with 2. Can you see that? Please follow through. Make sure you pay attention because it's not difficult. It's just to simplify this expression that seems large. All right. So in this way, we have the result as sy multiplying 1 over x plus y to the power 3. Then let's just work on this within the square brackets. So this one we have s cubed plus y to the power of 3 over s cubed y cubed. All right. We're coming to this first term, but let's finish the work with the second term. Plus 3 over sy multiplied x plus y to the power of 4. All right. Now this term, this first term in the curve parentheses can be written as x plus y all squared minus 2sy. All right. This s squared plus the sum of two squares can be interpreted like that. Then everything divided by sy plus 2. All right. Now it is not hard to see that this last term can we reduce to writing sy multiplying 1 over s plus y to the power 3 s cubed. Now this s cubed, let me quickly do something here. Okay, before that I think, okay, let's put things in place first before we make any work in order to avoid confusion. Then plus 3 over sy x plus y to the power 4. All right. Now on division, we have this as x plus y all squared all divided by sy. All right. Then we have minus 2 plus 2, which we cancel out, and that will give us just this term. All right. Hope you agree with this, what I did here. We're using the law that a plus b over c can be interpreted as a over c plus b over c. All right. So s will divide each term, leaving minus 2, then plus 2 will cancel out. So we're left with this term over here. You see, you can see that the expression has reduced to a more form that is appealing. All right. So this cannot be written as xy multiplying 1 over x plus y to the power 3 multiplying s to the power 3 plus y to the power 3 over s cubed y cubed. All right. Then plus this cannot be interpreted as 3 over we now have x squared y squared multiplying x plus y to the power 2. Can you see that? See how far we have gone in the work. The next thing we shall do, we shall still simplify further. All right. Now observe, let's take common factor once again. Let's look at what is common. If you observe carefully, you discover that we have some things in common. All right. Now this is a sum of two cubes. The sum of two cubes can be interpreted as follows. This is equal to writing sy 1 over x plus y to the power 3. All right. Now this sum of two cubes can be written as x plus y multiplied by x plus y all squared minus 3sy. It is a fact that the sum of two cubes can be written like this, or divided by s to the power 3 plus y to the power 3. Then we have plus 3 over x squared y squared multiplying s plus y all squared. All right. I think let me take more page so that we can continue the work process. Then we have xy. This can be written as 1 over x plus y squared. You observe that this will cancel out, then this denominator become this. Then we are left with this result. Please take notes. This is not addition. Let me remove this from here. This is x to the power 3, y to the power 3. All right. So the work has been simplified to a very considerable form. So this can be written as s plus y to the power of 2 minus 3sy. All right. Then to be very fast about the work, I don't want to waste much time on rewriting things that are not that necessary. Now, observing this, the denominators of these two terms, that is this over here and this over here, you will see that uh, s to the power 3, s to the power 2, y to the power 2 is common to both terms. Because that is common, we can factor out, we shall have x squared, y squared. That will leave us with sy here. Can you see that? Yeah, we are left with plus. All right, we're left with plus 3. Then I can put this bracket. Please take your time to observe what I've done. Uh, there's no confusion at all. Look at it carefully. You see that is the case is this is the case. Have you seen it? Observe it carefully. We can have this as a result. All right. So having it said, let me add more page now. All right. Having it said, we have our result as equal to xy over, or rather, we can even say 1 over sy, because this numerator will cancel out with the denominator. We have that. All right. Then we're left with 1 over x plus y all squared. Then when this divide individually, we have x plus y all squared over sy minus 3sy, which is, and that when that divides, we have just 3, as we did in the first case. Then on cancellation, everything breaks down to 1 over sy. Then this will cancel out with this. All right. So think the work is done. Then we're just left with this. So and this become the sorry, square, not cube. All right. Then this can okay. Let's leave it like this. So therefore, our left hand side, the left hand side, indeed simplifies to this expression. All right. So we're done with simplifying the left hand side. So let's go back to the right hand side. Let's see what is the right hand side. What is the right hand side? The right hand side here is 1 over the square root of 6s squared minus the cube root of 64s to the power 6. So we simplify that. So we take this squared expression and try and simplify as far as possible. All right. So the right hand side, that is the RHS, is equals to 1 over the square root of 6x squared minus the cube root of 64x to the power 3. All right. We have this, and this can be written as 1 over the square root of 6s squared minus 4 to the power 3, s to the power 3, all raised to power 1 over 3 from some elementary rules of indices. All right, so we have this as a result. And this can also be further simplified as the square root of 6s squared or minus 4x. Oh, I see there's a problem. I'm coming. Let me see something, whether I will copy the right question. Okay, look at it over here. The result is s to the power 6, not 3. So I come here and put, that means this will become 2. All right, so this is 6. Please take note of that. So become this. Then on subtracting, we have the result as the square root of 6 s 2s squared rather. 2s squared, all right, which becomes 1 over, we have x root 2. Oh, sorry for this. This is not what I intend writing. s root 2, all right, equal to have as a result. That means the right hand side can equally be written as x root 2 all raised to the power minus 1. Can you see that? Sounds interesting. All right. So, but don't forget, in the equation, we are given that the left hand side is equal to the right hand side. So, since that is the case, our left hand side is already obtained to be this, which can be written over here as sy all to the power of minus 2 equal, the right hand side is this already, so we have x root 2 all to the power of minus 1. On taking on raising both sides of the power minus 2, we have our result as sy equal to x squared times 2. That will give us 2x squared, all right? So working this further, we have sy minus 2s squared is equal to 0. On factoring, we have that x brackets y minus x is equals to 0, all right? Now, from here, we can find the value of s because we are given in the equation. Let's go over to the equation. We're given initially that s plus y is equals to 4, from whence we can make y the subject of the formula. So if x plus y is equals to 4, we have that y is equal to 4 minus x. So that means our y is equals to 4 minus x, all right? So that means this last statement can be written as x multiplied, in place of y, we'll put 4 minus x equals 0. From whence we have s multiplying 4 minus 2x, all right, equals 0. It led us to having s equals to 0 or 4 minus 2x equals to 0, from whence we have x equal to 2. Now don't forget that our x and y, they are bigger than 0. So this result here will be discarded. This cannot be a possible value of x, all right? Now if x is equal to 2, that means from this equation over here, we have that our y is equal to 4 minus 2, which gives me 2. Therefore, we can say s is equals to y, and each of them is equal to 2. And this is the result. So the result is 2. So take your time, go through this particular problem once, twice, and thrice, if possible, because uh, repetition will enable you to get a proper grasp of a concept that is being taught. All right. So if it's not clear to you, you can reach back to me, and I'll try my best to make it clear to you. So thank you very much for paying attention. I really appreciate your presence. So enjoy yourself with the solution of this particular problem. It looks like a monster, but it's very easy to decompose.